Actually, I have also invited some of the students who will be joining our program from this August 2021. So I can see that few they have already joined this um, yeah, in the Zoom. Yeah, Dr. Locke, can you hear me?
Yes, yes, I can hear you clearly.
Okay, okay.
Good morning, everyone.
Yeah, I think Sila also joined, right? Yeah, Sila, are you there?
Yes, Professor. Good morning.
Yeah, good morning. It's very nice to see you here. Yeah.
Thank you.
And Wendell also joining, right?
Yes, he's joining. He's on his way because he's from a meeting right now.
Okay. Yeah, it's fine. This is a seminar series. So we organize this seminar on a bi-weekly basis. So once in every 2 weeks, and two students presents their research work, right? So yeah, you have plenty of opportunity to listen the research maybe in coming days also.
So good morning, everyone. So may I request everyone to turn on their video at first, just to say hello.
Yeah, Dr. Locke, please do not forget to take the photo also, right?
Yes, definitely, definitely,
Yeah,
sir.
we
Yeah.
might have 2, 3 windows. So maybe.
Yes, sir. Yes, sir. Keeping a close eye on that. So please, everyone, let us turn on the videos and take one photos of private, a group photo of everyone. This is a new practice during this social distancing, but it's good for everyone that see more faces, lively faces. Um, so just a reminder that this event is going to be live on Facebook. So I request each of you, if possible, please share this event to your network so that this event, this meaningful event, can reach out to a larger audience. Thank you. So it will be, it's basically on live on Watch Engineering and Management Facebook page. Thank you. So I can see that there's still some people that have not turned on their videos yet. So Gangcha Rastraka is Mr. Talampas or also Rabin. May I request you to turn on your video? Thank you. Okay, we still have someone. May I request you to turn on your video as well, please? Hello, the remaining, please turn on your video, please. Rabin and Radi, Abishka. Good morning, Devesh.
Good morning, Dr. Law.
Good morning. Good morning, Sudep. Okay, so I think for some reasons, yeah. Okay, so Roel, can you, and then I will also take pictures from here before we start. Okay, so good morning, Parichat. Morning. Okay, so everyone, look at the camera and on my mark. 1, 2, 3, cheese. Okay, one more time, 1, 2, yeah, someone is connecting. Okay, one more time. 1, 2, 3, cheese. Perfect. Thank you very much. Okay, so first, I would like to say thank you everyone for joining this third event of WEM Seminar series. And this event is happening today in a very occasion of a holiday. So first, I would like to wish you, express my best wishes to all of you and your family in this holiday. And before we start, may I request everyone to mute yourself. And then whenever we have go to the Q&A session, you can raise your hand and then mute yourself for Q&A session. Okay, so is everyone looking at my screen at the moment? So welcome again to WEM Seminar Series on May 26th of 2021. So today presenters, we will have a presentation from Mr. Truempak Pakel and Mr. Muhammad Latif Hossain. Okay, so let me take some couple of minutes to introduce our first presenter, Mr. Truempak.
Hello, can you hear me?
Yes, sir. Yes, Devesh. Okay, so Mr. Trembach,
Yes, sir.
he's currently a PhD student candidate at our department, Water Engineering and Management. His research interests includes river health assessment, hydrological modeling, and land cover and climate change. So today, Mr. Trembach is going to share with us his research on land use, land cover classification using Sentinel-2 satellite images using Google Earth Engine. So with that, I would like to pass the floor to Mr. Trembach to begin his presentation. Thank you. Please go ahead, Mr. Trembach.
Thank you, Dr. Law.
Yes, please, you can start share your screen.
Can you see my screen?
Yes, already. Thank you.
Okay. Okay. First of all, I would like to thank Dr. Locke and WEM for providing this opportunity to speak. And hello everyone, I am 𝐓𝐫𝐸𝐴𝐚𝐦𝐻 from India, currently doctoral student of Water Engineering and Management. My research interests include water modeling and watershed modeling and management, land use change mapping, impact studies of land use and climate change on hydrology and water resources. The topic of the talk is land use land cover classification using Sentinel-2 satellite image and Google Earth Engine. Mainly this topic was the part of a project funded by AIT as research initiation grant under principal supervision of Dr. Mohna. So I was involved in this project under guidance of him, and these are the outlines of my presentation. So basically, land use land cover mapping is done for analyzing the crop growth, biomass extraction, and yield assessment and climate change detection. So mainly this land use land cover maps, we use very basic input for hydrology and hydraulic model for water resource studies. Even these land use land cover maps are used for crop area mapping, which because we require this crop area in monthly basis. So and even this flood related event based studies require land cover map for that event. Many studies in past have used global land use land cover product available with coarser spatial and temporal resolution. So advancement in satellite imagery and availability of data product make easy to generate our own land use land cover map with fine temporal resolution. So mainly we have lots of satellite data product available. By using that we can generate our land use land cover map. So some of these satellite data products are like Sentinel product, whose data are available from 2050 till present, Landsat data product, whose data are available from 1984 till present, and Esther and Modi's data which are available from 2000. Among them, Sentinel-2 image have the very good spatial resolution of 10 meter.
Excuse me, Mr. Trembach.
Yeah.
May I request you to zoom in or make it full screen so that we can read some of the text?
Okay.
Yeah, now that's better. Thank you.
Yeah. So mainly this Sentinel-2 imagery have these all satellite products have multi-spectral bands with visible range, near infrared band, and shortwave infrared band, and some of the thermal imagery bands. So these bands are used to classify our images into land use land cover map, and these bands are also used for various purposes based on their application. So main problem we face when we classify our land use land cover map is related to accuracy. So accuracy depends on the spatial resolution of the image, and also depend upon the availability of cloud free image at that time, and number of training sample data which we have taken for uh, reclassifying that spectral bank to our land use land cover map. And classif also it depend upon the at what time that image is obtained from the earth. And when we do this land use land cover classification, we face the problem of misclassification. So sometimes due to same spectral response, what happens, this for example, this crop area pixel will be classified as forest area, or sometimes forest area is classified as crop area. And because of their same spectral reflectance at that particular time. So and we also use some another method like phenology based classification like Ndvi, which is normalized difference vegetation index, and Ndwi, so which are used to classify based on the vegetation or based on the water bodies. So Ndwi is the normalized difference water index. So these values can help us to classify these images based on this index value. So our objective of this research was to improve the classification accuracy of the land use and land cover mapping, and uh, to improve the classification accuracy of the land use land cover using vegetation and water indices rule based classification approach. And we use this vegetation and water indices rules, and also we compare this our approach with the existing approach, which are the algorithm related same as random forest and classification and regression tree methods. And also we applied this proposed methodology to an regional scale to generate the land use land cover map of that area. So so as I already told, that sentinel image have the 10-meter resolution and uh, in the visible range, and 20-meter resolution in the shortwave infrared band, and it also have 10-meter resolution temporal resolution, which means that in every 10 days the satellite will take the picture of same place. And this satellite was launched by European Space Agency. And so we have used this satellite product to prepare the land use land cover map. So for this we have used this Google Earth Engine, which is a web-based tool for interactive data exploration. So before when we used to process before having this Google Earth Engine, there were we have to download our data and process that data in our own system, and we require lots of computing speed. But what this Google have did, they have collaborated with Earth Engine. So they have the all satellite image of past 40 years, and we can run our algorithm in their web-based portal and obtain the end result, and only need to download the end product what we got. So right side we can see the image of the data center of Google Earth Engine, where they have stored the all the maps and satellite images. So this is our proposed methodology for this research. So we obtained we got the Sentinel-2 image, and then we compute the median component of for that particular month image. So a Sentinel, as I told, it have 10-day temporal resolution. So approximately 3 times satellite image have been taken and calculated the median of that images, and based on the band we calculate the NDVI and NDWI. So NDVI is calculated based on the bands like near infrared band minus red band divided by near infrared plus red band. Similarly, NDWI is calculated based on the formula that near infrared minus shortwave infrared divided by near infrared plus shortwave infrared band. So based on this, we get the NDVI values and NDWI values. So we have combined these NDVI and NDWI values uh, by editing, by adding and subtracting, and form a obtain a particular range of value for each land use class. And second thing what we did, we have the training, means we gave the training data set based on the physical observation of urban area, forest area, and water bodies by as a training data set, and use the cart and random forest algorithm, and uh, and obtain the classified image of the land use land cover, and test with the this obtained value of NDVI and NDWI. And additionally, what we do, we took the image from 2016 till 2018 and calculated the mean monthly component, and use the harmonic relation of NDVI and NDWI for that time series, and uh, use that calculation for total variation of NDVI and NDWI signal, and these values we have compared, and uh, have based on this we decide some range and classify this image into forest area, cropland, open land, water bodies, and urban land. So for that we have taken our study area at northeast of Thailand, Rachantani, where we have tested our algorithm. So first I told that we have calculated the NDVI values. So as you can see that here the cropland and forest land have some overlap of NDVI values. So this will cause uh, the false classification of the image into false range. And similarly, as we see this barren land and urban pixel are lying in same area for some places, so that pixel also will be classified in wrong way. So similarly, we have used NDWI, uh, uh, means normalized difference water index, and calculated the values, and the values range for forest area and this cropland area. You can see the clear some different distance in that, but urban area and this open land, these have the overlap. So the classification of urban land and this open area cannot be done, and also this cropland and water body also have overlap area, overlap range, so we cannot classify this uh, based on NDWI. So what we did, based on this range, we have used NDVI and NDWI. We have added it and we have subtracted it. So we plotted the range again, and uh, so based on that we can see that our this cropland have uh, uh, separated from the forest area, clear separation from the forest area, and even water bodies have the clear separation uh, from the other classes. So again we have some little bit of overlap of forest land and cropland. So to overcome that issue, we have used the third algorithm, that uh, harmonic, and based on that we have calculated TVMS, and uh, this is the threshold value. By using that we can have the clear separation between the uh, NDVA values uh, forest land and cropland. So we have tested this 3R algorithm. So these are the three rules which we got, and based on these three rules, we have classified our land use land cover map in 5 classes without any means with more accuracy. So we have tested this method and compared with this cart algorithm, and as you can see that this image is of March 2018, and the accuracy obtained using uh, cart algorithm is 0.79 percent, and means 79%, and uh, and with our 3R method we have obtained the accuracy of 96%. And also we have tested this same algorithm for winter season for November month. For that we got, for cart we have the accuracy of 79%, and for 3R our proposed method we got the accuracy of 93%. And similarly we have compared this same with random forest classification. So for March month we have accuracy of around 80%, and for overall uh, for proposed method by us we got accuracy of around 94% for the summer season. And similarly for winter season we got the accuracy for random forest method is only 68%, and with our proposed method we got accuracy of 93%. So based on this we found that uh, the 3R method with cart is performing better. So we have used that algorithm and uh, uh, generated our means land use map for 2019 for each month, and with a accuracy varying from 80% to 95% uh, with different months. And these are the results, and we can see in June, July and August there are a lot of images are missing. These are missing due to cloud cover, because of rainy season we don't have the image of that area, but other area wherever we have the images that have been classified in, and we have obtained the land use land cover map of that area. So these maps can be you have the temporal resolution of, and based on these maps we can do assessment related to agriculture area change and other things. So um, I can conclude that this land use land cover classification accuracy has been improved by 3R based classification system, and traditional classification method incorrect classify the forest and cropland, and urban area mix the urban area with open land because of its spectral characteristic, and the error classification of forest and crop pixel were significantly corrected using our 3R method. And there are some a drawback of our method are like we can not classify exact means land use land cover without training data set. So we have to provide some training data sets for accurate classification, and also we need cloud free image, because these our sentinel image which are in visible band cannot penetrate the cloud, so we need passive remote sensing images. And we need to test this algorithm we, to some of more area to come up with more accurate suggestion that okay, this algorithm is widely used globally, we can use this algorithm like that. So thank you.
Okay, so thank you, Mr. Trambach, for a very insightful and meaningful presentations. So before I open the floor for Q&A session, I can see that we have a lot of new participants who are both either alumni of WEM and then also the junior students who are going to join us in August. So everyone, so please join me to give an applause to welcome all of the alumni as well as the new students who's going to join our WEM family from August 2021. So everyone, please use this icon, applause, to welcome all of these new participants. Thank you, everyone. Okay, so thank you for all the applause, audible and visible as well. So let me open the floor for Q&A for Mr. Trambach. So please, thank you.
Hi, can I have a question?
Yeah.
Yes, please, Dr. Kun. Thank you.
Yes, my name is Chuan. I'm the postdoctoral researcher in WEM. So thanks for a very nice presentation. It's not a question, but I want to ask for more clearly. So you mentioned here the result was improved by applying the 3R classification. So I mean, what kind of data you compare the accuracy? You compare with the you say here the reference data. So I don't know what kind of reference data. You have some actual data or not?
Yeah, we collected some actual data and form our confusion matrix, and based on that we got this accuracy assessment.
So my concern is like the lump sum number. You have any kind of the distribution, the actual map to compare, and the time of the developing the map and the time of the like a satellite image.
No, we took some sample point using Google Earth,
No,
and
okay.
And based on that we have did this accuracy assessment.
No, okay, I see. So your estimation and analysis mainly depend on the satellite and also the Google Earth. So
Yeah.
I think it's much better if you can looking for some actual data like the map, maybe in the same duration or same year. So it will improve your confidence in your research. It's not like mainly depend on the satellite image only. It's my comments. Thank you.
Okay, thank you.
Yes, thank you, Dr. Tuấn, for your very useful comment. And I see that Mr. Ganja have one question, so please go ahead, Mr. Ganja, please.
Hello everyone, I'm Ganga Shrestha and I'm currently studying in Central Department of Environmental Science, Nepal. So my question is, how many maximum training samples do we need to select for maintaining high accuracy?
How many we cannot decide, like it's depend upon the image we have, and means training. If we give more training data set, it will be the probability of more accurate result will be there. So if we use less training data set, then accuracy will be less.
So is there any range?
No, we don't have any range, because we have to means select the pixel and pixel values for that. So we generally do it manually for providing this training data set. So we zoom it and select that area. So based on that, we at least we should have very good number of training data set.
Okay, thank you. So
Yeah.
my last question is, can we use base map for high accuracy?
No, this is we cannot use base map, because this is temporal variation, na? So mainly if we use some base map and digitize our means we give our sample data of agriculture land. So maybe that time that land is not cropped. So when based on your base map, we cannot give that, no? Maybe when we prepare that base map, that time that agricultural land is not cropped, so it will not classify as agricultural land. You got my point, what I want to say?
Yes. So when we will be doing for the temporal analysis, base
Yeah.
map is not
Yeah.
good to use. For that, we have to use band classification.
Yeah, we have to use a false color composite classification.
Okay, thank you.
Yeah.
Okay, any more questions? I think this is very useful presentation, for especially for those who are using remote sensing for their research. Rabin, you have any comments or suggestion in this? I think you use also the similar techniques for your research, right? Hello, Rabin. Rasmin. Oh, sorry, Rasmin is not here. Okay, so I will ask one question.
Yes, sir.
Yes. No, let's give the floor to 𝐿𝐺𝐵 first. Yes, please go ahead, 𝐿𝐺𝐵.
Good morning, everyone. I am 𝐿𝐺𝐵 Sharma. I am currently doing Master's Engineering in WEM department. My question is in slide number 17, there is a missing images due to a cloud impact. Sir, have you tried Sentinel-1 image for that? Because Sentinel-1 image is the SAR image, and SAR image didn't have any cloud penetration. So have you tried Sentinel-1 for that work?
I cannot try that, because I am calculating Ndvi, because our algorithm required Ndvi and Ndwi values, which required this visible range, that is R band. So R band cannot penetrate the cloud. You got my point?
Yes, I got, but sir, in Sentinel-1, I think is C band is also there, so maybe it will work on that.
But our algorithm don't work on C band and this. It only work on near infrared and the shortwave infrared and this R band. So based on that only we have classified these images. Maybe the C band image, I don't have idea about it. Maybe I can see related to that, but current algorithm cannot be used using that SAR image.
Thank you, sir.
Okay, so one last question from Warruth, because he's yes, yeah. Please go ahead, Warruth.
Okay, thank you for a great presentation. My question is, what are the factors affecting NVDI value with respect to the time change?
NDVI.
Yes.
VI.
Yeah, V.
Okay. So NDVI. Okay, I will show you one. Yeah. So with monthly. So this is the plot. You can see here are the values of NDVI monthly. This is we have fitted that with this equation, and based on that we got that there is a lot of variation in the NDVI values. So you want to know the range, like for a forest area, what is the range, like that?
No, I mentioned about a factor, for example, like a crop canopy that will affect it for the NDVI value or not.
Crop canopy will affect the NDVI value or not? Yeah, NDVI values for crop, it will lie in a range of 0.3 to 0.5 generally. So but we cannot distinguish that. Okay, maybe this is crop or this is forest. That's why we have used this time series from 2016 till 2018, so that if there is repeated number of means high NDVI value in that point, so maybe it is forest. So that's why we have that particular separation based on that.
Okay, thank you.
Yeah.
Okay, so thank you for your question and also response from Trembach. I see that we still have a lot of questions, but considering the time, so please divert your question, either send to Mr. Trembach or send to my email, which is hoholok@ait.ac.th to follow up questions. So because his time is ticking, so may I invite our next presenter, Mr. Latif. So, okay, so yes, Mr. Latif, please spend a couple of minutes to introduce yourself, your topics, and then before you start the presentation. Thank you. I think you have to unmute, Mr. Latif.
Okay. Good morning, everyone. Do you hear me, everyone? Hello?
Yes, 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 we can hear you. Thank you.
I am MT Latif Hossain. I am Executive Engineer, LGD, Bangladesh. I am working with the local government engineering department, and I just completed AIM engineering from AIT in water management, water engineering and management department, and I completed my graduation bachelor in 2003 from Bangladesh in Rajshahi Institute of Engineering and Rajshahi University of Engineering and Technology. And today I'm gonna tell you about my thesis work, that is statistical downscaling of regional climate model data sets under heterogeneous terrains. In this thesis, my research advisor was Dr. Mohana Sundaram, and my examination committee, there are 3 more committee members. They are Professor Babel sir, Professor Sangam sir, and Dr. Wadis. Outlines. These are the outlines. Introduction. We know climate is actually average weather. Average weather is at least 30 years average weather, usually we call climate. Climate change is also a long-term weather change. Climate scenarios, IPCC declared some climate change scenarios. These are RCPs and SSPs. And for climate change impacts, as we know that we are human beings are observing impacts from the climate change, and for climate change, it's global warming, and water availability also now is the issue. Here some images. Here some figures, just like here we see that the surface temperature is rising, and these are the scenarios, 4 scenarios, and each scenarios have some different projections, and these are some figures. These are some world climate for RCP and SSPs for RCP scenarios. For this reason, actually, we need to understand climate dynamics. So for this reason, there are so many climate models to predict the climate, future climate. For this, GCM is the prominent, but its resolution is higher, more than 100 kilometers. These are the GCM grids, and for RCM, it is the resolution is less, just like it's about 50 to 25 kilometers. But this RCM are product of GCM. It is downscaled, and it become final resolutions. And there is 2 ways for actually downscaling is a process. This process is from GCM. This grid have to resize to desired scale. Actually, for impact assessment studies, we need finer resolution data sets. That's why there are from GCM, it is downscaled to our desired scale for impact assessment studies. And for downscaling, there is a two process, that is statistical downscaling and dynamical downscaling. In this thesis, our objective was to develop fine resolution, precipitation, and temperature variables for impact assessment studies by statistical downscaling approaches. Specific objectives was we incorporated lapse rate for downscaling to make it more accurate for monthly time scale of rainfall and temperature dataset. We evaluate our model performance, and we develop fine resolution future dataset for rainfall and temperature from RCM. This is our study area. This is a Wang Basin. This Wang Basin is in the northwest part of Thailand. Actually, this area is heterogeneous. So it is in these three provinces in this basin. There is three provinces: Chiang Mai, Tak, and Lamphun. And these are the two stations. We have meteorological two station. We have and these are the data we used for this study. We collected meteorological station data for Tmax and Tmin and rainfall for daily basis, and we collected from 1970 to 2005, and we convert it to monthly data. We collected Aphrodite data for 25 kilometer resolution, and we convert it to monthly Aphrodite data. We collected RCM data for historical 2017, 2005, 2022 for historical, and 2021 to 2050 for future data for RCP 2.6 and 8.5. This is also 25 kilometer resolution data. And we also take DM data and we convert it to 5 kilometer DM data. We also convert the Aphrodite data to 5 kilometers. Actually, in this in this study we calculate PLR and TLR. PLR means precipitation lapse rate. TLR means temperature lapse rate. This is a 5x5 window. If we want to calculate this grid, this is a 5 kilometer grid, and for with a time series of 36 years, we for this lapse rate calculation, each and every month we calculate, we take all this data, all this 5x5 25 data. Here Aphrodite is our dependent variable, and each grid have their elevation. Elevation is our independent variable, and from this we calculate the slope for this grid for each month of the of our baseline period, and for the following grid we take the it's green 25. This way all grids have been calculated for both precipitation lapse rate and temperature lapse rate. This is our overall methodological framework. We take Aphrodite data, and this is our Aphrodite data, this is our RCM data, and this is our station data. First we from Aphrodite we convert to 5 kilometers, and we just check whether this Aphrodite data is okay or not. That's why we checked with the station data to validate this Aphrodite data. This Aphrodite data and RCM data we RCM 25 kilometer data we downscaled to 5 kilometer resolution using two model. One is multilinear regression model and one is a linear regression model. In linear regression model we just use 25 kilometer, the 5 kilometer Aphrodite and 25 kilometer RCM data. This is one model, that is a linear regression model. And for multilinear regression model we use Aphrodite 5 kilometer data and RCM data and our lapse rate. This way we create this model for multilinear regression and linear regression model. Then we validate this model. We just compare both of the model by using these three performance indicators, and then we select the model which is better, and we project our climate change. We project climate change for RCP 2.5 and 8.5. This is our multilinear model. Here we see that our predicted is Aphrodite data. This is 5 kilometer resolution. This is our monthly data. X1 is RCM monthly data, and this X2 is our lapse rate, which we calculated, and these are the coefficient and intercepts. And we also create another only simple linear regression model. Here and these are the three performance indicators we actually use. That is mean absolute error, root mean square error, and coefficient of determinations. This is the feature projecting model. That is our MLR multilinear regression lapse rate model. We project from 2020 to 2050. Here this is our future projected Y cap is our future projected monthly data. X1 is from our multilinear model, we get x1, this variable, and we got these two from that model, and corresponding sorry, this is the feature data for RCP 2.6 and 8.5, and for this A and B is the coefficient from our model. Now, first of all, after when we these are the appropriate data and station data comparison. First, we validate our appropriate data. We converted 5 kilometer appropriate data. We have two station. We check the station data and that appropriate grid data with scatter plot, and we found that for monthly rainfall, R-square value is very good, satisfactory. For Chiang Mai and Bahubal Tech, both of them above 80%, and for mean temperature, R-square value is very high. This is the one image for this is appropriate data, converted 5 kilometer appropriate data. This is the average of 1970 to 2005. Here we see that for each month there is spatially and temporary it varies, and also this is for temperature. This is the lapse rate for average lapse rate images, and for TLR, this is also TLR, and we evaluate its performance for monthly rainfall data. This is for our linear regression model performance. Its MAE and RMSE is 0.75 degrees Celsius per month, and R square value is above 0.75 for rainfall. For monthly mean temperature, we have got MAE, RMSE both around 0.75, and R square value is 0.75. For multilinear regression, MAE value is 25 millimeter per month, RMSE is 50 millimeter per month, and R square value is around 0.75. And for multilinear lapse model, monthly mean temperature, MAE RMSE value is around 0.75 millimeter per month. R square value is grid square is above 0.75. Now we calculate how much MLR value multilinear model is better than our linear model. Here we found that for MAE and RMSE for monthly rainfall, it is about 10% improved for each grid, for almost every grid, and for R square value also around 10%. Some grids improved more than 20%. And for monthly mean temperature, MAE RMSE also decreased. It is decreased about 10%, and for R square value, it is almost unchanged. We did box plot we checked our baseline Aphrodite and our two models, and we found that multilinear regression model, it captures the extremes better than our linear regression model for rainfall, but for temperature, actually both the model perform almost same. We checked it for the two station grid only with the study area, within our study area. These are the extreme indices performance checking. We for 95 percentile and 5 percentile. For 95 percentile, we have seen that almost each and everywhere multilinear for two station, multilinear regression perform better. For 5 percentile, R-square value is same. For monthly mean temperature, for 95 percentile and for both 95 and 5 percentile, both R-square value is same, but but here we see that it is not performing good because multilinear regression error is more. This is our feature projected data set, where we see that actually for RCP, for RCP, these images are the changes from our baseline period to our projected period for RCP 2.6 and 8.5 scenario. Here we see mostly actually for 𝐿𝐴𝐷. This is we separate three season for according to the rainfall intensity. In for May, June, and July, we have found that almost it is decreased. The grids are decreased in this month in our study area. For August, September, and October, there are few northern parts. There is some increment, but still there is some unchanged. And for November, December, January, February, March, and April, we have found that northern part is decreased, and here some grids increased by 10%. Conclusion. We got conclusion that left side incorporated multilinear regression based statistical downscaling model performance is better than simple regression based statistical model for monthly rainfall and monthly mean temperature. Monthly rainfall has a declining trend in most grid in our study area for RCP 2.6 and 8.5 scenario. Multilinear regression left rate monthly rainfall model capture better than linear regression rainfall model in extreme indices, 95th among 5th percentile. Multilinear regression model, multilinear regression monthly mean temperature model perform inferior to our regression model for the extreme indices, 95th percentile for temperature model actually, but both of them R-square value is same, and it is high. Recommendation. Actually, in our study, we recommend that we calculated, we only study for monthly basis, and up to 5 kilometers we downscaled. It can be downscaled more finer resolution, and also for temporal resolution, it should be can be do for daily basis, even hourly basis. For lapse rate, it can be used to predict other variables also. We just take one RCM. If more RCM can build our confidence more. The model performance was evaluated to an elevated place. Actually, this we do in a elevated heterogeneous terrain. We didn't check it to a plain land. And land use and land cover, it can be incorporated in the climate prediction model. Thank you very much.
So thank you, Latif, for giving a very insightful presentations. Actually, I particularly like the part that you spend a lot of time to go through the method that very comprehensive. So now I would open the floor for 1 to 2 questions. So please, thank you. Everyone, if you have questions, please unmute yourself and then ask question to Mr. Latif. Thank you. Hello, Santos. I think you're working also in climate change, right? So can you have one question to on comment to Mr. Latif? Santos.
Yeah, hi everyone. I'm Santos Tungana, currently a research associate in WEM department. Yeah, I have one question. You have resampled the Aphrodite data set to 5 kilometer grid resolution. How did you compare the RCM of 25 kilometer resolution grid to 5 kilometer Aphrodite data set?
Thank you very much. Actually, we here you see actually with lapse rate, actually we take 25 kilometer resolution, total surrounding grids, environmental what I say, climatic phenomena to that grid, and this way actually we just downscale by regression. Actually we regression to Aphrodite because Aphrodite data is 25 kilometer resolution for the Asia, except except in Japan. Japan has got 5 kilometer resolution data, but other than area don't have any 5 kilometer data. That's why we convert Aphrodite to 5 kilometers.
Yeah, my question is, how did you compare the 25 kilometer RCM grid with 5 kilometer resolution Aphrodite dataset?
Oh, actually, here we didn't compare. Actually, we just here Aphrodite data is our observed data, and we downscaled 25 kilometer RCM data. We downscaled to 5 kilometer using Aphrodite. You got my point? We didn't compare actually. We in this slide we actually compare with Aphrodite data with that specific grid, with the specific grid data for validate that our converted Aphrodite data is okay or not.
Yeah, I mean, based on your explanation, that you have compared the Aphrodite data set with the station data set at the point scale. I mean, you first extracted your Aphrodite data set to the station points, then you compared with the station data set, right? Then you validated your Aphrodite, then you used it to downscale the RCM.
Yes. We just we converted data by inverse distance weighting method. For Aphrodite data, we convert to 5 kilometer by inverse distance weighting method, IDW.
Yeah.
And we just check whether IDW our converted data, how the performance of that data, so that we justify the data using the point with that specific grid data set, and the Aphrodite that converted data set, we checked the data, how the data is justified or not for using our next study. Okay.
Okay.
Thank you.
Yes, thank you, Santos, for your question. So may I invite, we have here Rabin Bastola. I think he's also working in the topic of climate change. So Rabin, can you have some comments to Mr. Latif, please?
And thank you for this opportunity. Actually, I don't have questions to Latif now. So I learned a few things that are useful for me. Thank you, Latif, for this interesting presentation. Yeah, thank you.
Thank you, Rabin. Thank you, Rabin. Okay, so I will just have one small question to Latif. So after you have done all of this, downscaling, so what kind of recommendations that you can make for the management of the catchment of water resources?
Actually, my study is not impact assessment study. I just project the future climate and what I say, final resolution future data projection is here.
Yeah.
But and I found that in the study area in future there is a trend of precipitation decrement. This is this trend I found, and for this reason maybe there should be more studies also required to what kind of thing should be for adaptation and for mitigation this kind of situation. What should be done? It should be need more study, I think.
Yes. No, actually, my point is all of your information is valuable, but how are you going to convert the information so that the managers of the basin themselves can make use of your findings? So my suggestion is, instead of stopping at the step where you convert that, this is very meaningful scientifically, but my suggestion is to think a bit ahead that, okay, so how this information can be useful for society, or in this case, the management of water resources. Yes.
Yeah. Actually, in this study, we created the future data set from 2021 to 2050 for the 5 kilometer resolution data set for three provinces, that is one basin. So that for impact assessment study can be used, because you can for impact assessment study more finer resolution data is required. So this data set can be used for the impact assessment study for 5 kilometer resolution. With that area, they can use it for their future any kind of developments. They can use this data.
Yes, thank you, Mr. Latif. Okay, we have one suggestion from Mr. Usaf Batarai. So, Mr. Usaf, maybe you want to share that with everyone here as well. Hello, Mr. Usaf. Okay, so I will just read from his chat. Okay, so his suggestion is the orography and aspect play quite important roles in climate variables in heterogeneous terrain, which is your study area. So his suggestion is to incorporate these into your regression analysis as well as in the future. So we can consider these aspects in the recommendations of your research. Okay, so I think we are a little bit, behind the time. So thank you again for this, for today's presenters. And this is a holiday, so I want to extend my wishes to all of you and your family. Thank you, everyone. And then we will meet again in 2 weeks. Thank you.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye, everyone.